today I'll learn some components about the Docker daemon. So first we have to see that what is a component which is most useful, you can say the exam purpose or interview purpose. So some components required for this exams perspective, or you can say the interview perspective, right? So the component of Docker daemon, we can say that first is Docker daemon, Docker's component. From exams perspectives or interview perspectives, some components may ask related to Docker component, right? So component, what should be the component? The first one will be Docker daemon. What is a Docker daemon? Docker daemon basically nothing but it runs on the host operating system. Suppose we are installing Docker's engine on the host operating system. Like suppose that this is the Unix as Ubuntu. Above the Ubuntu, we have to install Docker engine. This Docker engine is also called Docker daemon. And also it is responsible for running the container to manage Docker services. Suppose that we have created the container. These containers required some port to execute their applications. So port number is mentioned over here, but container doesn't have the IP addresses. IP address is taken from the host operating system, right? Like just like Ubuntu. Ubuntu is the host operating system, and IP address. Suppose that Ubuntu operating system has 192.168.1.1, and containers which is under the applications which is under the container which is running on the port number 80. So then these services IP addresses of the host operating system and port will be the containers port. Then it will run the proper application. So basically the Docker engines are also responsible for running the container to manage Docker services, right? So for this, Docker engine is responsible, right? Docker engine is provide the services for the IP addresses of the host operating systems and port number, combine the port number 80 of the application and run their application over the internet.
Yeah.
Yes,
Yeah.
I'm getting the point. So Docker engine's gonna act like a middle layer. Most of the things that the container wants to pull, Docker engine will help, especially assigning the port or the pulling the IP address from the operating system.
Yes, correct. So if anyone talk about what is Docker daemon, then you can say that Docker daemon is nothing. It just run the host operating system, and it is responsible for running containers to manage Docker services. And another will be the Docker client. So Docker client, basically Docker user interact with the Docker daemon. Suppose that this one the Docker server, right? Docker server, or you can say the Docker engine running on operating system, then create the container, right? And we have the one Linux machine, right? One Linux machine just like a laptop. And in Docker engine, which is running with the root user, suppose. And we have created one Docker user. So from this Docker user, we have connected with the Docker client and run with the Docker user. And Docker user give the instruction to create the container with the Docker daemon. From here, we can instruct the command. So you can create a container over this Docker engine. So this one is Docker client. We cannot exactly run the command over the Docker engine, but we have to connect it with the Docker client like our laptop and give the instructions. Suppose that we are accessing instances using the PuTTY, right? And user is EC2 user, right? That is default user of the AWS account, right? Or AWS Amazon Linux. And we are using we are accessing instances over the PuTTY. So PuTTY is a client. Same kinds of we can use the Docker users using the PuTTY client. That PuTTY client is called Docker client. We can give the instruction, give the command from the Docker client to Docker daemon right, to create the container or run the application over the container. We are accessing Docker daemon using the CLI or REST API. REST API. So we can access through this CLI and REST API, right, to connect with the Docker daemon and give the instruction from the Docker client. See, the thing is that we are connecting Docker server from the PuTTY, and on the PuTTY write the instruction create Docker run -it and container name, contain not a container name, it's a image name like you want to, and bin bash. This instruction we are passing through the PuTTY, and that PuTTY connected to the Docker server, Docker instances, and create the container from the CLI, correct? And this PuTTY is the Docker client. So PuTTY is using on the Linux machine. In the AWS instances, we are installing Docker using root privileges, right? Root user. So instance, whenever creating the instances, default user is EC2 user. We can install Docker using EC2 user, also using sudo privilege. So apart from this user, we can create another user that like Docker user. And on this user, we can give the root privilege. And on this Docker users, we can install the Docker daemon. The thing is that how can we give the full privileges, our root privileges of the Docker user? I have clearly mentioned in the Linux tutorial, right? For referencing, you can go ahead with the Linux tutorial, right? Now, we have installed the Docker daemon on the Docker users. And Docker users, we can use these Docker users over PuTTY also. So suppose that this is on the Windows laptop, and on this laptop, PuTTY is installed, right? And PuTTY, we have to connect with the public IP. Then we have to give the public IP. Then we have give the credential. After that, we have to select this user, Docker user, not EC2 user or root user. So once connected with the Docker user over the PuTTY, this PuTTY is called client. This is connected using the CLI. So via REST API also we can connect, we can pass the instruction over the Docker daemon, create the container or run the application inside the container. Now through the API, we are passing the instruction to create the container like Docker run -it, image name like you want to, and bin bash. We are passing this instruction with the REST API to the Docker daemon. Docker daemon is nothing just like a Docker engine which is running on the host operating system. Then we are passing the instruction, and after passing the instruction, Docker engine create a container over the or host operating system. This REST API is called Docker client. Docker client should be used using CLI and REST API. Any question?
No, sir.
Now, one component is Docker host. Host is used to provide the environment to execute and run the application. This is the operating system. This is the hardware, right? Hardware, you can say the hardware or server. On this server, running the operating system like Ubuntu, and over the Ubuntu, Docker daemon is running, engine or Docker daemon. Then we have to create the container. Docker host is responsible to provide the environment to use and to execute and run the application. That means suppose that this containers running some application, right? Like mobile app. So for this mobile app over these containers need to require more dependency file, right? For mobile application, right? Suppose that this application is running on the Java and Python and some other dependency required. So how can Docker containers use this Java and Python? So in this case, the Docker host, that means this one is Docker host. This is the server or Docker host. We can say the physical server or Docker host. Docker host is responsible to provide the all dependency for this application over the container. suppose it is Java. So Java should be in the Docker daemon, should have the Docker daemon, right? Python should have the Docker daemon, right? So how can we keep the Java and Python in the Docker under the Docker engine or Docker daemon over the Docker daemon? Here I said so any images required for running the application need to download from the Docker Hub and it keep on the Docker engine. मैंने बताया था ना कि Docker Hub से pull करके यहाँ पे रखते हैं. I'll explain again, right? Or what the hardware devices running the operating system like Ubuntu. Over the operating system, we have installing the Docker. Now we have to run one application which is mobile based, and these applications required some dependency file, right? Suppose that this mobile based application requires Ubuntu and Java and Python. So suppose that we have write a code for this mobile application. This write a code. We have write a code, and after that, writing the code need to require this Ubuntu operating system, this Java platform, this Python language, right? To run the application, run the code. So for this, we have to download the dependency file from the Docker Hub. We have downloaded Ubuntu, Java, and Python. Not downloaded, we have pulled from the Docker Hub, this file, this dependency file. And we have, then after that, we have to create the container and run their applications. So environment is provided by the host operating system. Host operating system. This host operating system is called Docker host. Now another component is Docker Hub. Docker Hub basically restored and managed the Docker images. Right? Suppose that Ubuntu image, Ansible image, any applications related to things just like Git image. So lots of image you can say that all vendors images should be available on the Docker Hub. Docker Hub is nothing just like a public repository you can say. So Docker Hub provide two types of repository. One is public and another is private. So public repository, that means images is available on the public repository, which is open source, free of services. And images are available on the private repository, that is the chargeable. So we can create our repository also over the Docker Hub, right? Suppose that we have created one images. We have created one images, right? This image is created for the testing purpose, or this image need to share with the another person, another location. So we have to push this image over the Docker Hub on the private repository. So we can create our private repository over the Docker Hub, right? And another person, we can say that you can download from, you can pull from the these images from their Docker Hub. Suppose that one company, suppose that XYZ have the two locations, right? One is in US and another is in India. And US developer created one images for mobile application. Mobile application. They want to share, US developer want to share the images for the India developer. And these images contains or sensitive file is contains in under this image. So how can he share to the Indian developers? They can, the US developer can push their images in the private repository of Docker Hub and say to the Indian developer or email to the Indian developer, we have pushed these images to the Docker Hub and you can download from the there. Like Git repository, right? Now, there are three ways to create container, Docker container. First one is image. We can download image from Docker Hub. We can download the image from the Docker Hub just like Ubuntu and create the container. The command will be docker run -it and Ubuntu bin bash. This is the first way to create the container from the images Docker, which is available on the Docker Hub. Second one, we can create container, right? Suppose that we have to create the container to Ubuntu, and after creating the container to image, and then create a container. This is the another way. So first we have to create a container and we have to write some files under the container. Suppose that I have write file one. I have created one file one under this container. Again, this container, after creating file one under this container, we have to create images of this container. Once images is created, then after that, we can create the container from the images. Suppose that one developer, this is the US developer, create a container with the for the mobile application, right? He created container mobile application. Indian developer created container mobile application and mobile application up in running over this container. Now need to share this application, mobile application to the Indian guy, Indian developer. After successfully running the application under this container, they create the images with this container. And this image shared to the Indian developer. And Indian developer create container from this image. So there is another way to create the container. Third one is Dockerfile. What will be in Dockerfile? I have to create one Docker file, and be under this Docker file, we have to pass the instruction. Suppose that what we have to do, right? Suppose that we have to run an operating system like Ubuntu, and on this Ubuntu we have to run an application, and we have to copy the file from the local directory to the containers. So we have write one code under the Docker file, and after creating the Docker file, we have to create the image from the Docker file. And once image is created, then we have to create the container. So this is a third way from Docker file. So first one we have earlier described over the lab, and second one, third one we are going to describe, right? And so on.
Yes.
Now have directly moved to lab. Now we have to create EC2 instance, right? So EC2 instance, select EC2. Now launch instance, Docker server, Imagine Linux. Now create a key pair, ppk, Docker key 1, create key pair, select HTTPS traffic and launch instance.
I have one question while this is initializing. Okay. So, what are the different ways we can use Docker server or Docker daemon? Like one is the EC2 instance, right, from where we connect. Is there any other way we can use Docker?
So this is the for the testing purpose. We are just creating one instances, right? This instances is also host operating system, you can say. So suppose that we have to create the Docker daemon, right? So we can create Docker daemon over the cloud, over the on premises, right? Or over the hybrid cloud also.
Okay, so there are different ways where we can install and use Docker, right? Okay.
See, we can install Docker daemon on the Linux-based operating systems only. This is the predefined, right? And the
Okay.
Linux-based operating system we can use over the cloud, public cloud, private cloud, hybrid cloud, or on premises, right? So the cloud might be the different vendor, either AWS, either Google or Azure also. The functionality will be same. Here we are creating EC2 instance. If we talk about Microsoft, then we are creating the virtual machine. We are talking about the Google, virtual machine over the, we can create the same kinds of virtual machine we can create Google Cloud also. Now a status check is 2 by 2 completed. It's passed. And this instances is called host operating system, right? Where we run the Linux operating system. So now we have to access these instances using the PuTTY. Either we can directly connect with these instances using UI interface, right? So just we have to click and connect, select and connect. And this default user is EC2 user, right? Now we have to connect. This is the AWS interface provided for the Amazon Linux. Now tell me it's clear.
Yes, it is.
So this is the EC2 user by default. Default user for the Amazon Linux is EC2 user, right? So what we have to do first, we have to move into the root user, sudo su. So sudo su, after entering sudo su, it will goes to the root privileges. So over here we can create another user also, right? Like user add and docker add user, docker user add. So default user is EC2 user. I have created one user, right? Docker user. Now I'm disconnecting this one. Right now it's a EC2 user. Default user is EC2 user. So we have two users. So how can we check we have two users over here? It's a cat etc password. So we can check the users over here, right? EC2 users, default user, and this is the users. So we can basically we can access Control L. We can access these instances using the two users. Or right now it's a three users. One is root, another is EC2 user, and now we have created one user, that is Docker user. Right. Now we are going to root user, sudo su. Now it's move into the root user. This user, EC2 user, doesn't have the sufficient permission to install the Docker daemon. We can install Docker daemon using the root user only. Right? If we provide the sufficient permission to the, then we can go ahead with the EC2 user also. Suppose exit we are doing existing. Now it's in under this EC2 user, that is default user. Now we are installing yum install Docker. See, this command doesn't have the run the super user privilege. This command has to be run with the super user privilege. That means the root users. The sudo privileges over here. So just we have to write sudo and yum install Docker. Then it will work. Right? Why? Docker is installed. Control L clear. Which Docker? It's located location provided over here. USR under the bin under the Docker. Where is Docker located? Docker's installed. This location is Docker is installed. If we have to create the Docker is installed, right? And after installing the Docker, we have to start the services. Sudo service start. Now Docker service is starting. For any command, we have to write the sudo first, right? That means we have to provide the sudo super user privilege to run the command. If we go with the root privilege, sudo su and control L, then no need to write sudo before the command, right? Just like service docker status. Now it's running. Now service is running, active and running. Q, press Q to quit. Control L to clear the terminal. So suppose that we have to pull the command, pull the image right here now. No images in this Docker daemon under this Docker daemon. So for the images, any image available or not, we have to write a command Docker images. No images in the local repository. So suppose that we have to pull the command, so pull the images from the Docker Hub, any Docker images, Docker Hub, search the images like Ansible. Ansible images is available, and we have to write the same Ansible oblique Ansible, right? For the Ansible, its image is available. This image, using this image, we can create the Ansible container. Now there is no image in the local repository, right? Now we have to pull the Ubuntu is available over here. Image is Ubuntu or Ubuntu Nginx. Both images are available here. Just we have to write any image we have to pull from the Docker Hub. Just we have to write Docker pull and Ubuntu. This images is pulling from the Docker Hub, right? Now have to check images is pulled from Docker Hub or not. So Docker images, we have to write a command Docker images. Now Ubuntu is pulled from the Docker Hub and kept into the private repository of the Docker daemon. Now from this Ubuntu images, we can create a container. Just like for creating container from the images, we have to write a command docker run it and image name, then bin, then bash. And container is created, right? You can check the ID of the container. And right now I'm inside this container. We can check ls and we can find out the lots of directory under this container. And this container is Ubuntu image container created from the Ubuntu images. Now we can check what operating system for this container cat etc os-release. This is the Ubuntu. So first lab is completed. If we exist, then Docker container will be a stop state, right? Control L. Now we have to write command docker ps-a. It's a exited mode. Status is existed mode about a minute ago. Now we have to start this container. So we can just write a docker start and container name. But see over here, there is no name of this container. Default name is created. Suppose that we have to write a container with our name. So we can write a container docker run hyphen name, and we can provide the container name like container1 and Ubuntu image, which from which image we have to create Ubuntu, and then -it, then bin and bash. Docker run -it name, container name just I'm writing here. Oh, one container one and Ubuntu from the image, then bin bash. Now container is created. Now I'm existing from the container and running the command docker ps-a. Right here his name is container1, right? Container and container1. So we can provide the name during the container creation, flagging --name. Now container, we have created the container from the images, which is downloaded from the Docker app. Now we have to write a command docker run -it. Then we have to give the name web server, and we have to check the images which is available engine x same name we have to write over here engine x, then bin bash. We have to create a container which is directly downloaded from the Docker Hub. Docker engine is intelligent, right? We have to just give the name of the which server we have to install over this container. In this case, Nginx web server will download and create a container bin bash. Now it's downloading, pulling completed, and containers created. Exit. Control L to clear the terminal. Docker ps-a. Right. So ps-a basically tells us the what is the stop and start state of the containers, right? So all containers are in the currently stop state. This is existing, and this container is up and running, right? 16-minute Yogo created container one. But I think it's not created properly because its a timestamp is not showing over here. So we can check that these containers, what is the status of these containers, copy of the containers name and Docker start containers. Now it's error, right? Basically containers is not created properly, right? This is syntax error, something like this, fail to start create. So suppose that we have to delete this container, right, which is not properly created. So we have to write a command docker rm and container names only, right? This container is deleted now. Docker ps-a to check. Now container has gone. Three containers is in a stop state. These three containers are in a stop state. One is web server, another is container one, another is gen. Now, how to start this container? Docker start and container name. Suppose that web server is container name, then we have to provide the web server name over here. This container is started now. So how to go inside these containers? This is basically started now. We write a docker ps command only. So started container showing over here. ps-a, it shows the stopped and started container, but the ps, only ps, docker ps, it shows the only started containers. Again, docker ps-a typing. Now it's showing the started and stopped container. right? It's up 37 seconds. Creation time is 17 minutes, but status is 37 seconds. Control L to clear the terminal. Now, how to go inside this container, right? Docker PS. This is the running container. We have to copy this container ID or container name. Both are same. We can go ahead with this container ID or container. So going into inside containers, we have to write a command docker attach and container name. So I'm inside this container. Which container? This container's ID, right? 6 is C7. 6 is C7. Here we can write the ls command, list command. Then we can see the lots of directory is available over here. Temp directory, USR directory. We have to create one file under this temp directory. So what should we do? Go inside the temp directory. Temp. Now we have to create file. Create a command touch file1. File1 is created under the temp directory of this container. CD then exit. Then we have to exit. Docker ps -a. Under this container, we have created one file, right? That is file1. So how can we find the difference between the base containers and updated containers? Okay. So how to compare the the base containers, and under this base containers, we have created one file. So one command should we write over here, docker diff, that means difference of the container, right? So create the container name over here. Container name is web server. It shows the C. C, that means C refers to change. Under the temp file, we have changes. We have write a file name, right? We have created a file name. And A refers to the addition. What is added? File1 is added under the temp directory. Then change the root. C refers to the change, right? Root and this bash repository. Where should we write the files, file1? So these differences we can find from the diff command, right? Docker diff and containers ID or containers name. It shows what is the differences between the base images and the updated container. Control L to clear. Now we have to write the command docker ps -a, and this is the updated. This container has been in a stop state right now. Clear this terminal. Docker commit update web server. I'm giving the web server name. Images we are creating from the container, right? And which container? Web server bin was.
It should be vice versa, I guess. Okay. It should be web server and then image.
Docker, just Docker commit web server and image one. Now it's created. Yeah. So now
That's
it's
right.
created images, right? From this container. So Docker images. Now image one is there. So second way to create a container from the images. First we have to create the container and update the files under that containers. Right. Then we have to create the images from this container like image one. Now we have to create container from this image. Docker run -it name updated container latest container from image one, then binbash. Now we have to check that this file is available in this file1 is available under this container or not. So
Right.
ls-temp file1 is available. There are two ways we have learned.
Third way is Dockerfile, right?
Third way is Dockerfile. Right now, I think it's sufficient for today.